In this video, I am going to show you how to draw a deterministic finite automaton given non-deterministic finite automaton. Okay, for this we are going to show the steps how to find the different states of the DFA and the transitions between these states. Okay, the alphabet of the language will be A, B. Okay, according to the NFA. Let's find the different states of the DFA step by step. Okay, let's draw the transition table for the DFA. Okay, let's put here in the columns the two symbols of the alphabet A and B. Okay, and let's look for the initial state here. Okay, so the rule here is to find the epsilon closure of the initial state of the NFA. Okay, given that the initial state of the NFA is 1, we'll compute the epsilon closure of 1. Epsilon closure of 1 is the state 1 and the state 3, since we have an epsilon transition between 1 and 3. Okay, so the result will be the set of states 1, 3. For sake of simplicity, we'll write it just 1, 3. Okay, now we have the initial state. Let's look for the transition with E and the transition with B from the set of states 1, 3. Okay, again, according to the NFA, the transition with A from the state 1 is pi, because we don't have any arc here going from the state 1 with the symbol A, but the transition from 3 with A is 1 and 3. We'll take the epsilon closure here, 1 and 3, since 3 is related to 1 with the epsilon transition. Okay, and then we'll take the union of these two sets. Okay, the union is 1, 3. So we'll write down the result here as 1, 3. Now for B, we'll use the same rule and we'll look for the transition from 1 with B, which is 2, okay, and the transition from 3 with B, which is 5 here. Okay, we don't have any arc going from 3 with the symbol B, and the result will be the set of states 2. We'll write simply here 2. After looking for these transitions, we find here a new state in the DFA. We need to know what is the transition with A and what is the transition with B. So we'll write down 2 here and again look for the transition with A and the transition with B. Okay, according to the NFA, the result will be the set of states 2 and 3. Okay, from 2 with B, we have only one transition, which is this one. It's going to 3, so the result here will be 3. Again, we have two new states here, 2, 3 and 3, and we need to know the transitions from these two states. Okay, we put them in the rows of the transition table. Now from 2 with A, the result will be 2, 3, and from 3 with A, the result will be 1, 3. Okay, the closure of 1, since we have here an arc going to 1 and another one going back with epsilon, so we'll take 1 3 together. And now we'll compute the union of these two sets, which will be 1 2 3. We'll write it simply here as 1 2 3. Okay, now from 2 and 3 with the symbol b, okay, here we'll compute again the transition from 2 with b, it will be 3, and with 3 with b it will be nothing, so the result here will be 3. Okay, we have here a new state that we shall write here in order to compute for it the transitions with a and b. Okay, now for 3 with a, we know the result here, it's 1 3. Okay, 3 with b, it's 5. We don't have any arc here going from 3 with the symbol of the alphabet b. Okay, now for 1 2 3, the transition with a is nothing else but the union of the transitions from 1 with a, and from 2 with a, and from 3 with a. Okay, from a it will be 5, from 2 it will be 2 3, and from 3 it will be 1 3, and the union of all of these states will be 1 2 3, so we will write here 1 2 3. For b, we know that from 1 the result will be 2, from state 2 the result will be 3, and from 3 the result will be 5, and the union of these 3 sets is 2 3. We'll write here 2 3. Okay, note that this phi means that there is no arc from 3 with b. Okay, so we can draw it here, and it will be the dead state. Okay, we can say that with a we are going to phi, and with b also we are going to phi. Now once we finished all the states in the transition table, we have just to draw these states and the transitions between them in the diagram of the right. Okay, in the diagram we specified that 1 3 is final state, also 1 2 3 is final state, because the rules say that we take the final or accepting states of the NFA, and we look for the states in the DFA which contain one of these final states. As you may see here, the only accepting state in the NFA is 1, so all the states in the DFA containing 1 will be accepting. Okay, so 1 3 and 1 2 3 here will be the two accepting states of the DFA. Okay, so here you are with the DFA that we show the steps how to obtain it from a given non-deterministic finite automaton. Thanks a lot.